Hello everyone, thanks for being here today. I will describe the research work I have done during this year. I'm an industrial PhD student in the thesis school. We will go through basically what I've done, what contribution I've done, and so forth. The title of the thesis you have is Multi-Properties-Based Partitioning for Embedded Application. We will go through the motivation and the background. We will discuss the research problems, what is motivating this research. We will look into the objective and research questions. We will discuss what is my contribution to the state of the art. We will present the case study. I will discuss conclusion, and we will see how to proceed towards the PhD after this. So let's start with just a quick picture of embedded systems. Embedded system applications are in several domains, getting more and more complex. This one is increased the complexity of embedded system in general. We have more functionalities, new services. We have a lot of standard legislation to comply. Even in the future will be more. We have new service to develop. We have software technology to integrate and several communication to technology and scenarios to fulfill. So basically, this complexity is reflecting also in the development of embedded system from different perspectives. We can say from the functional and service point of view, from the non-functional requirements. We can see it from hardware and software technology, how to integrate, how to best use this one in the most efficient way. We have a lot of new methodology. They are still evolving all of the times. And of course, also from project and business constraint perspective, this one increases the complexity of developed embedded systems. So if you look now down into the latest technology in form of heterogeneous platform, it means platform that they are basically consisting of several computational units, for instance, FPGA, CPUs, and GPU. This kind of platform provide a valuable support when it comes to this increasing complexity and also to meet the performance. But on the other hand, they bring new challenges. And one of these one is what is the optimal deployment configuration of an application. So what does it mean this one? More in details. Given an embedded application, how I should divide this one into hardware and software? Which part of the application I should deploy as synthesizable? Which DL, for instance, code if I'm dealing with an FPGA, and which one has executable C code, for instance, if I'm working with a CPU. So, based on this one, if you look at the state of practice today, basically, when it comes to the decision on how I should divide, so it should be hardware, software, which part I should put it on the FPGA and which one on the CPU. This deployment decision, partitioning decision, basically, they are taken ad hoc and based on experience that the software and hardware teams they have. They are also based on a limited number of physical metrics, for instance, on performance, on power consumption, on physical memory size, and so forth. And also, they are taken in an early stage of the design when not all of the information are mature enough, where we are dealing with imprecise or imperfect information. This one, if you look at the picture there, we have a simplified overview of traditional development process if we go for the requirements phase into design, implementation, verification, and validation. This one, what it happens is that the design of hardware and software is basically very soon in an early stage of the design divided into two different flows. And the integration of the system came in a late stage, which lead to some issues might be like flow interruption or redesign or unwanted changes or several iterations. So basically what we can state as is it matter of fact, we have the lack of a methodology that is systematically support how to perform the application partitioning, deployment decision. And what we notice is what is actually also taken into account in the current state of practice is that aspects related to life cycle or project and business constraints are not taken into account in this decision process when we decide which part to deploy as hardware or software. Based on this one, we formulate the research problems that our research work has focused on. And one is how to define a systematic and efficient process that supports the hardware and software partitioning of this application. That is the first research problem and the first question we look into. And basically what we wanted, or what is the aim, is to have, if we look on the traditional development process, what we want to have is to have a new development process which will be more systematic and which is allow actually to take into account hardware-independent design and software-independent design in the first phase of the design phase, and later to have hardware-specific design and software-specific design in a late phase of the design, basically to push more further the separation between hardware and software. The second question related to what we are discussing today is how to include all possible properties and concerns that are affected by the partitioning in the decision process. So, as I mentioned before, the state of practice that very few properties are taken into consideration. There is an example. So, what we want to say is, how is it possible to include all of the extra-functional properties that affect the partitioning that are important in the development process before we perform the decision into hardware or software? So based on this one, we formulate 3 research questions, which I will go through now, and I will start reading this one. So the first one, what will be a technology-independent process that enable the application partition in a late stage? So I want to have hardware-independent, software-independent technology design in the beginning, and then push the technology-related design in a late stage. The second one is how I can support the engineer. So how to enable a systematic decision process that is able to support this engineer in performing this decision and this partitioning of the application, and at the same time enable their use, which means also an increasing of efficiency of the development process. And the third one is how to obtain an optimal and sustainable partitioning solution also for the future, which take into account all of the properties related to the system requirements, business constraint, goal, project constraint, such that they affect the partitioning of the application. How I can include all of these aspects into my partitioning solution? How I will be sure that the partitioning solution has taken into account all of these one. So, based on this one, we will go through now the contribution with respect to the research question. So the first contribution is related to a design process. This is what is the contribution. In this case, we have designed a process, many, which is a systematic and support actually enable a technology-independent process from the beginning and push the technology-dependent process in a later stage of the design. And for this one, we call this process MultiPar. This is the name we gave it. Here you will see a simplified overview of the development process. We start basically to apply combining model-based design and component-based design in our approach to model the application. We aim to identify, as I said, functional properties that are relevant for the partitioning and take into account before performing the decision. In our case, we are working with components and we want to enable reuse. So we have a number of artifacts. For instance, the component libraries that they are going to be that is contain a number of components that can be reused. So for each component, we are assuming that we have hardware and software variants when it's possible. There are new components that they don't have. But for existing components, when we want to enable legacy or reuse, then it might be the case. We need to actually identify which of these properties might be of interest, and we need to prioritize, so that is another steps of the process flow we propose. And the third one basically is the partitioning solution, which partitioning solution is based on multi-criteria decision analysis methods. Multi-criteria decision analysis method is basically a sub-discipline of operational research, which has been in the field for about 30 years. And what this one allows us to take into account is the fact that we can definitely support engineers over the entire process. We can dealing with the information that are heterogeneous, miscellaneous of information. They might be qualitative or quantitative information. We can also work with probabilistic information and deterministic information at the same time. We can handle a large number of requirements into account. The multi-criteria decision analysis has been applied in several fields today, including medicine, economics, or weather forecasts, and so forth. But for solving this problem in this way has not been applied today. So we want to be multi-criteria decision analysis be part of our process. The second contribution for doing this one, which is related actually to the second question, how to enable a decision process that is supporting the designer. Basically, to answer this question, we have developed a Metamodel. We have designed a Metamodel that is a component-based one, which is able basically to capture both hardware and software components in a uniform way. As I mentioned before, for each component we might have different variants, which might be hardware or software. So this model is able to capture all of the aspects of hardware and software once. And for doing this one, actually, we feel that it was not enough with that one, and we need to further, because we focus on extra functional properties, on how to handling extra functional properties for partition. We further extend our Metamodel with extra functional properties, more specification in details, and we have here a simplified overview of the Metamodel, in which basically for each variance related to a specific component, we can capture the hardware software aspect. We can capture, of course, the values and how the component is obtained, if it's estimated, if it's evaluated, and so forth. We have different metrics also, because according to different actually domain, some properties can be expressed in a different way. So using this Metamodel, we are able to capture this heterogeneity of hardware and software in a uniform way. So, and we are able also, as I say, to manage the complexity of the extra functional properties. The third contribution we can say is related to the extra functional property categorization. So we want, as we said, we want to include many of these extra functional properties, but which are of interest, which are basically related to the partition. So what we did it was to look into the state of the art of the partitioning, to highlight what are the extra functional properties of relevant, of interest. We look into the industry state of practice, what the experts they do today, is what they take into account when they take this decision. And we look into different quality properties. Basically, we look into the standard square. We look into the another atom-based model. We look into different other quality model like Laprie or McCall. Basically, the outcome was a categorization of these properties into 3 different categories, which are life cycle, runtime, and project business sustain. For each of them, we have subcategories, and we have identified a number of extra functional properties that are relevant for the partition. So basically, we have 44 properties, 31 in the life cycle, 31 properties in the runtime, and 24 properties in the project business constraint. So based on this one, it comes to know which are relevant with respect to the partition. And for doing this one, we went through a number of further questions to refine our research. And one question is, we want to know which are the extra functional properties of interest, and how this one, which are the ones that they affect the partitioning. So what we did it was to go, we actually perform an interview survey. We had 15 participants from industry and academy with different working experience from university and industry, different know-how. Basically, we balance also the investigation. We have 5 people with the hardware and software background, 5 people with the hardware background, and 5 people with software background. And we also look at their experience, so we have more than actually 15, 60% of the people that they have 15 years of experience in the field when it comes to hardware and software aspect. What we did it actually was, so we want to know what are the properties that affect the partitioning, and we further say 2 questions for the interview, and one is, does the partitioning choice, hardware or software, have a direct impact on the properties? That is the first question that we want to know from the expert. And the second question is to assure and achieve these properties, assuming that that has an impact. Would be preferable to have a solution that is implemented as hardware or software? How we can achieve better these properties? depending on the it might be hardware, software, or it might be that is irrelevant, so it means that both hardware and software are fine. Actually, here is an example of the result. Is it based on the classification we did? So here I'm presenting just the example related to the project and business constraints, but that is also done for the life cycle and the runtime properties. So basically what the first question, as we say, it was what is the partitioning impacts, and now is it important, these properties on partitioning? And basically here are the results. We have the most interesting one I'm just presenting here. So we have 21 actually of 24 extra functional properties that they have be considered have impact on the partitioning. Basically 60% above 60% of the participants had agreement in between. And then the second one was related, as we say, if you have these properties as we wanted to prefer implement hardware software or is not relevant in this context. And basically we had, if the dominance was that it's not relevant on the context, but there was a limited number of experts which prefer to have such kind of properties. We contribute by actually looking into the suitabilities of multi-criteria decision analysis for partitioning, because we say, okay, we want to use it, but is it this one really feasible? Is it possible to use it? To what extent it can be used? So what we did it was to look into, again, the state of the art in multi-criteria decision analysis, how it's been used. We look into the partitioning state of the art and the industry state of practice. And out of this one, we derive 11 criteria, which have been used for our assessment if the partitioning, if the multi-criteria is suitable or not. So actually, we have looked into method and tools. We have analyzed it to the degree to which that one can be used to support the partitioning based on these 11 criteria. And the result here is just a simplified view of the result, because we're looking into 37 methods, and then by reflecting we'll also look at what tools are available with respect to the implementation of that specific method. And basically we've seen that there is no method that fulfill all the 11 criteria at the same time. The one that is closest is evidential reasoning, which is fulfill 8 out of 11 criteria. Then we have NIADED, which is fulfill 7 of the 11 criteria, and then we have the rest with 6, 4, 5, and so forth. So that's just a result. I show just a limited number of results. What is interesting is to discuss and to highlight is that there are 3 criteria that are less fulfilled, basically. And for this one, we need to further have some investigation. The one that was absolutely not fulfilled is the dependency handling. When we talk about dependencies, that we want to support modeling the dependencies in between the extra functional properties. It means between the extra functional properties, and also what we wanted more is in between the components, because there can be some dependencies related to components that have to be deployed on the same, for instance, units, computational units. So we want to model this one, and none of them was suitable for doing this one. And there was less tools which are able to handle probabilistic based assessment and distribution and interval information, because we said that information extra functional property they can be expressed using different metrics. So we want to be able to capture all of these diversities. So that's it. We maybe in some cases require extra additional work to do some transformation or to reformulate the problem differently to be used. So that's the result of this suitability assessment. And then we say, okay, it's possible to use it, criteria for our purpose. And the question is, okay, what the process should be, how you should do it. So in the first case, we start to further define and specialize the process we have start with. And we start with the decision analysis. So once of the decision metrics, which is the key artifacts in all the process. Then we need to assign the weights down to the preference of extra functional properties. We need to assign the preference of the stakeholder, because multi-criteria decision analysis, we say, is well supporting to capture the preference of stakeholder. The third one is that we, of course, need to run the methods or apply the method to achieving the partitioning solution. Basically, we look into classification and ranking method, but the most suitable one is the one for ranking method. And of course, the latter steps is to performing sensitivity analysis, which in some cases, some methods they can also support this one, but in some cases it should be addressed separately. The other contribution we did it, okay, we saw the process flow, we can go into, we have something that is applicable, we can go through the multicriterial decision analysis. But the question is, how is this one actually integrable? We can integrate this one into development process. And basically, actually, look into what we have done, it was to use the IFS framework, which is a framework to integrate tools in between for embedded system developments with several benefits has been proved, like reducing time to market or increased quality and avoid, for instance, lock-in. And what we did it is based on this framework in which we have been working this JU Artemis project. We use this framework to basically integrate multicriterial decision analysis tool. We have basically the advantage of avoid lock-in tool and replaceability of multicriteria because we try with different multicriteria tool, and we have the possibility to actually perform semi-automatic partitioning decision process to support. So this was another contribution which is discussed also in paper 4 and 5. And then basically we get into the case studies. So okay, we have seen it a lot of interesting discussion, but the question is this approach really feasible? So actually we want to look into that one, and we still in the context of IFS, we look into and develop an application for a small wind turbine controller. And we see to what extent the process it was and if it was feasible to perform it. So we start by modeling, which was the first part of the our process flow. The application has a number of components interconnected, which are compliant to our Metamodels. We have highlighted we have components that are new and components, we had some components that we could reuse. Then we went actually into the second step, which was the identification on the extra functional properties on the top. This is just a simplified overview because we went through several of the properties, and that's just a screenshot. And we, in the same time, that is a simplified overview of the decision matrix. We have existing components and new components. So for some of them, we have our existing variants for hardware and software, and for some of them we created the so-called virtual variants that can be hardware software, and we want to know if we have hardware software and estimate the properties, which one will be the selected one. After that one, basically we went to the next steps, which was the extra functional properties prioritization with the support of experts. Actually, we prioritize what are the extra functional properties of interest. And then we perform the partitioning. And for doing this one, we have utilized two methods. One was the evidential reasoning, which was the one with high ranking score in our suitability analysis. And we look into also Promity, which was very interesting, quite similar in number of functionality that it was provided compared to evidential reasoning. So we achieve our ranking of the components. For each component, we have a different ranking. So we can say, for instance, for the sensor is the face, we have the same ranking. Another solution is preferable. And based on this one, we, as I say, we use IFS framework platform. We actually show that the approach with our solution, the partitioning solution we achieve and we get out from the multicriterial decision analysis, applying multicriterial decision analysis method is feasible. And basically we run it, the partitioning solution on a Zinc platform, basically as hardware components of two components. We automatically generate executable code to be downloaded based on the tool chain that we have seen it before. So basically we can just close the loop on what we have seen it. We started discussing in the beginning the traditional development process. And our question was, is this approach feasible? We can push and we can have hardware technology independent design in the beginning, push down into technologies hardware specific design later, and can we handle several extra functional properties? So the answer to this one from the possibility point of view is yes, we can do it. We have demonstrated to the case studies. So the contribution of what we are discussing are basically in publication on conference, workshop, journal, and magazine. All of these 5 are fundamental to the thesis, so are included in the thesis. And then we have some extra publications which are related to the thesis, but which are not reported, and which have supported the research work. So now we are at the conclusion time, close to. So what we have done is basically the development of a new systematic, the design of a new systematic methodology, which we call it MultiPar, to achieve the partitioning of an embedded application into an heterogeneous platform, and is able to take into account multi-extra functional properties. So that was our goal, and we, from a possibility point of view, show that this is possible. So if we look a little bit more in detail, just to resum the contribution, what it was, we designed this design partitioning process. That was one of the contributions. We look into suitable Metamodel to capture other software aspects, including the related extra functional properties. We have done a categorization of extra functional properties that are relevant for partitioning. We did an analysis of other software partitioning impacts on the domain of control and automation to see how this one impacts the partitioning. We have shown that multi-criteria methods, we've done an analysis and show that make a suitability assessment for this technique with respect to the partitioning. And lately we have done the integration of this proposed approach into a development process, which was this EFPs-based platform development process. So from this one, that is what we've done. We have seen it, and we will go through the actually future work, because that is just one milestone, but of course we want to continue our research in this case. And what we've seen it as first topics that we need to further discuss is how to model these dependencies in between extra functional properties and between other software. There are existing models to model dependency between the extra functional properties, but they are not sufficient. We want to further extend how to model also the dependencies between the components with so many actually extra functional properties. We plan to have a study evaluation of existing approach based on fuzzy and statistical technique to model imperfection, incomplete information, which are actually done it in the beginning of the design phase. So if it's possible to use this technique to complement MultiPar and improve its efficiency. We want to have a further specialization of extra functional properties, because we have looked into the control and automation domain, but we want to further see if they can categorization can be extended by other existing standard or other domains. And we want to increase actually the integrability of MultiPar by developing an IDE. And basically we want to run further validation, because we know that the process is feasible, but compared to a traditional approach, how much is more efficient? And if it's so, we want to know it's efficient, of course, that will bring some challenge in measuring how much this one or how effective will be to traditional ones. So with that one, I have concluded my presentation. Thanks for your attention. And I think we need to move to this.